A pleasant day, learners. Welcome to our discussion on social sciences. We are going to go through a discussion on social sciences geography in preparation for the end of year examinations. Right, as you understand, at the end of year, you're supposed to write a full examination paper out of 75 marks. So basically the content will be encompassing term 2 work and term 3 work and term 4 work. So with me here is a paper that we're going to use as the basis of our discussion. We are going to analyze the questions, and also we are going to give clarification on some concepts on those questions as to assist you in preparing for the end of year examinations. Right, so we go to our questions and try to analyze the questions and try to give the best possible responses. Right, we're going to start with our section A, which is comprising of the low order questions, which are multiple choice questions. Right, the first question is saying, what is weathering? What is weathering? You understand of the concept of weathering, right? The first response is saying the removal of material by action of rivers, waves, wind, or ice, moving ice. We understand that is a wrong response. B saying breakdown of rocks into small particles. That is the correct response. When we're talking of weathering, we are saying the rocks are broken down into smaller particles. That's the process of weathering. And also remember, our weathering happens in three broad types, which are, number one, we have physical weathering, and also you can call it mechanical. Then we also have the other type of weathering, which is biological. And then we also have the third type, which is chemical. So these are the broad types of weathering. And these broad types, they result in the rocks breaking down into smaller particles. Right, we'll move on to the next question. Our next question is saying, use source 1 to answer question 1.2 to 1.6. Right, if we are seeing there, we are seeing that those are some different types of weathering. If we check picture A, we can figure out, and picture B, you can figure out, and picture C, we can also figure out there. Right, so let's go to our questions. The first question is saying, which example of physical weathering does picture A represent? Which example of physical weathering? In this instance, we want the physical weathering process that resulted in that rock breaking down. Remember, with physical weathering, we are saying it is caused by the changes in the ultimate weather and climatic conditions, which result in the rock breaking down without changing its mineral composition. Examples, we are going to highlight the examples. Let's start by looking at our question. Right, we have abrasion. Abrasion is out. It's not an example of physical weathering. It's an example of then frost shattering. This rock here, we are looking at it. As we look at it, we can see that this rock has been broken down into two pieces, and there can be evidence there that it was because of frost shattering, which resulted in the rocks breaking down. Right, when we're looking at frost shattering, our response, which is correct, is frost shattering. How does it happen? We are saying with frost shattering, or what we call ice action, is also called ice action. How does it happen? We are saying initially a rock will be having a crack, let's say like that. That is our rock. And we are saying water collects in the crack. Like we are saying here, in the crack, we have water collecting in the rock crack. This is A. Then it moves on to stage B. Right, we are looking at a climatic situation here, whereby we are in a region that experiences very low temperatures. And in those areas, we experience the freezing of water because of excessively low temperatures. And we understand if liquid water gets frozen, it expands. If water is cooled, if it changes state from liquid to become a solid, it expands. So if this is liquid water which is collected in a rock crack and the water is freezing because of excessively low temperatures, it implies that the crack is going to widen. Why does it widen? Is now because this water here, which is collected inside here, is now in a solid form, is now ice. It was liquid water in the first instance, but because the water has been cooled down, it is now changing form to become a solid, and it expands. As it expands, it forces the rock wider apart. And also it implies that the crack will further widen and it will end up disintegrating the rocks into two pieces. That is typical of how frost shattering occurs. Right, moving on to the next question. Right, we look at question 1.3. It says, in which chemical weathering process do iron minerals in rocks react with dissolved oxygen to produce rusting? Rusting, we are saying there's a reaction of minerals in the rock, and the mineral is iron. And if iron is reacting with oxygen, we know that it forms iron oxide, which is in simple scientific terms, rust. So the question is saying, which chemical weathering process? Remember, when you're looking at this, we must always remember that we have the process of oxidation as our correct, because you're talking of reaction with oxygen here. Oxygen results in the process of oxidation. The reaction of oxygen and iron, which gives us iron oxide, which is in simple terms rusting, is the process of oxidation. Right, that is the correct response for question 1.3. Define biological. Biological, we must focus on the term bio. We understand that bio, it means life. So when we're talking of biological weathering, we are saying is the type of weathering that is caused by living things. And our living things, they can be animals or can be plants. Those two, they constitute part of bio, and they cause biological weathering. They are living things here. So if you are defining biological weathering, we can define it as plants and animals break up the rock. It is plants and animals that are responsible for the breaking of the rocks, because they are the ones which are the living things, the bio. Right, that takes us to the next question, which is question number 1.5. The question says, identify the chemical weathering process in picture B. Identify the chemical weathering process in picture B. Let's look at picture B. You can see how the rock looks like there in picture B. Weaker particles are being eroded. And what's the most likely process that resulted in that kind of weathering? That is an example of hydrolysis. That is hydrolysis. Right, moving on to the next question. The next question is saying, identify the chemical weathering process in picture C. If you have to look at picture C, we want to identify the type of weathering process here. This type of weathering process in picture C is response number B, which is carbonation. Right. Then moving on to question 1.7. How do humans cause weathering when constructing roads? Remember, we also need to look at the impact of human activities on weathering. Human activities, they also contribute towards the process of weathering. They also play a part in facilitating or speeding up the process of weathering, for example, through construction and also through farming. Some of those activities, they contribute towards weathering processes. So how do humans cause weathering when constructing roads? Right. We are looking at that situation there. It says by covering land surfaces with vegetation. No, that is wrong. When constructing roads, we actually remove vegetation. By allowing indigenous plants to grow. No, we cannot allow indigenous plants to grow when we are constructing a road. By clearing vegetation. That's the correct response. By clearing vegetation. Remember, when we are constructing, we have to clear vegetation. And as we clear the vegetation, we also expose the rocks to weathering. They are exposed to nature, the natural process of heating and cooling. And as a result, they will break up. Right. Taking us to the next question, number 1.8. 1.8, it says, in which way do humans increase the rate of chemical weathering? Let's note there, the question is specific. It requires us to figure out how humans increase the rate of chemical weathering. Remember here, we need to look at ways through which human activities contribute towards the formation of mainly acid rain. It's the one responsible for chemical weathering. So we want to look at the processes responsible for the formation of acid rain, which are done by humans as they do their day-to-day activities. Plowing on slopes automatically is wrong. Road construction is also wrong. Removing vegetation is also wrong. Then the correct response is vehicle emissions. When vehicle emissions are released into the atmosphere, we understand there is more of carbon dioxide released from the emissions, and it's going to dissolve in rainwater to form a weak acid, which is the acid which forms the acid rain, which is carbonic acid, and which is a weak substance which results in chemical weathering. So vehicle emissions, that's the correct response for that question. Then moving on to source 2. Source 2 is basically based on the river's longitudinal profile. Right, we'll just briefly discuss the river's longitudinal profile before we answer the questions. Right, when we are looking at the river's longitudinal profile, we are looking at the river from its source until it gets to its mouth. That's the longitudinal profile of the river. The river's longitudinal profile. Right. It shows the appearance of the river, how the river looks like from the source to the mouth. What are we talking about when we're talking of the river source? We are looking at where the river starts. Where it starts. That's the source of the river. Rivers start from somewhere else. That's their source. And the mouth is where the river ends. Remember, rivers end. They don't flow forever. They will come to a point where they end. So our source of the rivers, mainly our rivers, they start in high-lying areas, in mountainous areas, and they flow down the slope until they reach their mouth, which is usually in the seas or in the oceans. That is where most of our rivers end their flow, and that is where they discharge their volume of water. So when you're looking at this profile, we can divide it into 3. When you're looking at the river's longitudinal profile, it can be basically divided into 3 sections. The first section is called the upper course, like what you are seeing here. The first uppermost part from where the river starts is the upper course. Then in between, we call it the middle course, and when it gets to its mouth, we call it the lower course of the river. So there are typical features that you must always remember, which are part of the river's upper course. For example, if you're looking at the gradient of flow in the upper course, we said most of the rivers, they start in high-lying areas. Or if you can check here, this river is coming from a very high-lying area going down. So it means the river is flowing over a steep gradient in the upper course. And which also implies that the velocity of the flow is high, which means the speed of flow of water will be high. The water will be flowing very fast, which will also imply that there will be high erosive power. Erosion will be high because of the fast flow of the water. And you must also note that the nature of erosion that happens in the upper course is vertical erosion. And vertical erosion is that type of erosion which is responsible for deepening the river channel. And what shape of valley do we find in the upper course? Because of vertical erosion, the river valley is V-shaped in the upper course. And we also need to analyze and look at the nature of landforms that we find in the upper course. We find landforms like the waterfalls. We find also the rapids. We also find the gorges. We find V-shaped valleys. Those are typical features that we find in the river's upper course. So you must be well versed and you must be well familiar with the features of the river in the upper course. Then we are saying as the river continues to flow, it gets into the mid part of its flow. After we are done with the first part, the river goes to the middle course. How does the river look like in the middle course? What typical processes happen in the middle course of the river? Right, we are seeing that the river now is no longer flowing over a very steep gradient. The gradient is becoming gentle as we get into the middle course. Like if you can try to check around this area here, the river is no longer flowing over a very steep area. The area is now becoming gently sloped. So in the middle course of the river, you tend to find that the river will now be having a U-shaped valley. A U-shaped valley. The valley is no longer V, but now is U, as in U-shape, right? And also you tend to find that the velocity of the river now is moderate. It's no longer flowing very fast. It's now having moderate velocity. And the process is happening there. In the middle course, there is both erosion and sometimes there is some deposition happening. Right. The nature of erosion that happens is no longer the same as what was happening in the upper course. The nature of erosion changes. We said the nature of erosion in the upper course is that of vertical erosion. So in the middle course, we have typical of lateral or what we call sideway erosion. This sideway erosion does not deepen the river, rather it widens the river channel because it is happening on the sides of the river, which means the river's channel is going to get more wider and wider. That is lateral erosion. Then you can also check in the middle course, the typical landforms that we find as the river gets into the middle course. We find typical fluvial landforms like the meanders. And we can also find the oxbow lakes in the middle course of the river. So that is just a discussion of what you must also be familiar with. Then moving on to the lower course, our lower course of the river, you must also be familiar with how it looks like. We are saying in the lower course, the river now is flowing over a gently sloping gradient, which is almost flat. The river is now flowing over a landscape which is almost flat as it goes towards its mouth. As the river approaches the seas and the oceans, it will be flowing over an area which is almost flat. So when you're looking at the lower course, you must also note the typical features of the lower course. How does the river look like as it goes towards the lower course? Right. What you must note here is that the river is now flowing over a gently sloping landscape. The river is now flowing over a gently sloping landscape in the lower course, which is almost over a flatland, which implies that the velocity will be very low. If a river is flowing over a flat area, it means the speed of the flow is very low. And also, if the speed of the river is very low, it means the river does not have much energy to transport material. Then it means there is deposition happening. Deposition happens, is now depositing material that had been carrying because the river's energy is getting lower and lower. And also, if we check typical of landforms that we find in the lower course, that is where we mainly find our braided streams, and also we can typically find landforms like the deltas as the river is getting into its mouth. So basically, that's the idea of the river's longitudinal profile that you must have in mind as we try to figure out how we can answer the questions, right? But that besides the point, we're just trying to explain the idea of the river's longitudinal profile. Let's go to our focus area, which is our questions, and try to answer the given set of questions and try to justify the best possible responses in particular to a given question. Right. Our first question, 1.9, is saying, in which river course are canyons formed? The canyon landscapes, where do we find them? The canyon landscapes, we find them in the upper course of the river. So our correct response is in the upper course. Because of vertical erosion, we tend to find the development of the gorges and the canyon landscapes. So we find them in the upper course of the river. Right, then going on to the next question, identify the feature marked 6. The feature marked 6. Right, if we come here and check, our feature 6 is indicated here. We are seeing that our river is going this way and is going this way here. So what is this? This is a bend along the river channel. The river is winding. A winding along the river channel, we call it a meander. So the correct response there is a meander. A meander, basically, we are saying it's a bend in simple terms. We are defining a meander in simple terms. We are saying it's a bend along the channel or a winding of the river channel. The river channel is not flowing straight, it's not going straight, but rather it takes a winding, which is a bending. So if a river is bending like this, we call this the meander. Right. Moving on to the next question. Identify the feature marked 8. Identify the feature marked 8. Right, let's go back to our, if we see our 8 is here. If we try to figure out, this is our 8, it looks something like this. If you can check, that is our 8. So this feature here is called an oxbow lake. An oxbow lake is something like this. Right. After a river successfully cuts through a meander, it creates an oxbow lake. So that is typical of an oxbow lake. Right, moving on to the next question. In which course of the river is the oxbow lake found? Where do we find the oxbow lakes? Right, predominantly we can say the oxbow lakes, we find them in the middle and in the lower course of the river. They start from the middle to the lower, but most predominantly, let's say, our lower, we find them in the lower course of the river. Right. What kind of erosion takes place in the upper course of a river? I think we discussed that the major type of erosion is vertical erosion, which we said is the type of erosion responsible for deepening the channel, the river channel. It is responsible for the deepening of the river channel. Right. Moving on to the next question. Which feature is found in the upper course of a river? Which feature is found in the upper course of a river? Right, we also discussed about that. We find rapids in the upper course of the river. Right, what is the main reason for the formation of a waterfall? The main reason for the formation of a waterfall. Right, let me just briefly explain how a waterfall forms. Right, well, for a waterfall to form, we are saying we will be having alternate rocks, alternate layers of hard and soft rocks. Right, if this rock is hard on top here, and the river is flowing over, this rock cannot be easily eroded because it's hard, and hence it creates a cap. If there's a softer rock below here, this softer rock is going to be eroded and is going to be sustaining under the protection of the hard rock on top. So softer rocks are eroded until they become carved in like this. Then it means if water is flowing over here, the water will plunge down vertically because of the erosion which has happened on the softer rock, which is under the hard rock. And as a result, the water plunges down. It creates what we call a plunge pool at the bottom here. So basically, when a waterfall is forming, it forms because there will be alternate layers of hard and soft rocks. The hard rock will be on top of a softer rock, and the softer rock erodes inwards. And as a result, we have a cap of hard rock which protects the softer rock underneath. And as a result, if water is flowing over the hard rock, it has to plunge vertically down, creating a plunge pool at the bottom, and the water continues down the river channel. So let's look at the question and the responses here. What is the main reason for the formation of the waterfall? Our correct response is the water cascades over a layer of hard rock and erodes a layer of softer rock underneath. That is the idea of the formation of the waterfall. Right, number 1.16. Describe how the feature marked 8 is formed. Let's go and look at the feature. The feature, as usual, we said, as discussed previously, we said our feature is an oxbow lake at point 8. How does an oxbow lake? An oxbow lake forms from a meander. I think you understand. When a river is flowing and is meandering, there are two processes that happen there. There is erosion and there is deposition. Erosion happens on the outer bank of the meander and deposition on the inner bank. So we are saying two extreme ends of a meander advance towards each other. Like one meander is advancing towards the other, the outer banks are advancing towards the other until the river manages to cut across. And as the river cuts across, it flows through a straighter channel, leaving behind water collected in the oxbow lake. So our correct response here, if you are to look, is response number D, which says erosion narrows the meander neck to form a new channel. Right, moving on to the next question. What is a river load? What is a river load? Basically, when you're looking at the load, you're looking at the sediment which is being carried by a river. As the river erodes material, it transports that material from where they are eroded to some other point where the material is going to be deposited. So that material in transit, in movement, is the load of the river. So what is the correct response for that question? The correct one is response C, which says the total amount of sediment transported by a river. Right, let's move on to the next question, number 1.18. It says, at which course of the river is deposition most likely? Deposition, where does it happen? Right, we discussed about that. Deposition happens in the lower course. Material is deposited in the lower course. Why? Because the river's velocity is low. There is low velocity. The river is flowing over a flat area, which means with low velocity, the river has got less energy to transport, and then it starts depositing the load. Right. What happens when a tributary joins the main stream? What happens when a tributary? I think we understand what we call a tributary. Let's say we have this as our major river flowing in that direction, and then our tributaries are these smaller streams joining the major river. So our major river, let's say it's river A, which means B is a tributary, C is a tributary, D is a tributary. And these tributaries, they join the major river at a point which is called, this point of joining is called the confluence. So the question is saying, what happens when a tributary joins the main stream? The river decreases its speed? No. River increases its velocity? Let's leave it. River decreases its volume? No. River tributaries increase in number? No. So what is most likely to be correct is response B. River increases its velocity. The river's speed of flow increases because of increase in discharge. If a river has got more water, it implies that it also flows at a faster rate. So if a tributary joins, it means the river increases in terms of its velocity. That is number 19. Right, moving on to number 20. Where is the mouth of a river found? I think we also talked about that when we looked at the river's longitudinal profile. So our response is response C. It is found where a river enters the ocean. Where the river is ending its journey, when it's discharging its water into the ocean, that is where we find the mouth of the river. Remember, it's from the source to the mouth. Right, taking it to number 1.21. What do we call anything that can be used to satisfy human needs and has value? What do we call anything that can be used to satisfy human needs and has value? Right, the correct response is a resource. Anything that we can use to satisfy our needs are resources. We have energy resources, we have natural resources, we have renewable and non-renewable resources, we have man-made resources. Anything that we need to use to satisfy our needs is a resource. Right, define a natural resource. We are now more specific now. We have natural and man-made. So what is natural? The term natural implies that it's something that is coming from nature. And by nature, we are saying it's something that exists out of creation. Something which was not made by men, something which was created, something coming out of creation. That's natural. So what is the correct response there? Resources which come from the environment. That's the correct answer. Right, taking on the next question. Which one is an example of a natural resource? We want an example of natural, something which comes from the environment, something which comes from nature, something which is provided as a gift of nature. Right, we can look at water, is natural, petroleum is also natural, Railways is not natural. A cell phone is not natural, which means this one is out. A cell phone is here again, is out. If we look at this one, yes, a cell phone again is out. So our correct response is response C, which implies that petroleum, forests, water, and soil, all those four are natural. Right. What are renewable resources? We have renewable and non-renewable. Our question here is we want renewable resources. Right. Renewable, the correct response there is response B. We are looking at resources that can never be used up. Right. Renewable resources, we are saying they can regenerate if they are used wisely. If we use those resources in a sustainable manner, they can regenerate. For example, the forests, trees can be replanted or they can regrow. If we cut down a tree, that tree can produce shoots and regrow. Or alternatively, we can replace it by planting another tree, what we call reforestation. So if we use those resources, they can never be used up. Or wind can regenerate. It's a renewable resource. And the opposite is non-renewable resources. None, it means they will get depleted. They will get finished. For example, fossil fuels like coal. Coal takes millions of years to form, which means if we use it unsustainably, it will get depleted, it will get finished. Right, taking on to the next question. Which one of the following is an example of a non-renewable resource? We have talked about that. A non-renewable resource is coal. Coal is non-renewable. Which of the following selections are examples of renewable resources? We want a set of renewable resources. Right. If we try to check those ones, we can see that we have water is renewable, oil is out, is non-renewable. So this response is wrong because it has oil. If you also check here, oil is there, it's wrong. And if you also check here, oil is there, it's wrong. So our correct response is C, which has got fish, trees, and water. It implies that fish is a renewable resource in the sense that if we engage in sustainable fishing, fish will reproduce and they will never get depleted or get finished completely because they will reproduce if we do sustainable fishing. And trees, like what I've mentioned, they can regrow, and also water can be recycled through the water cycle, which means it's a renewable resource. Right. Taking to number 127. What do we call the processing of waste so that it can be used again? We have used some resources and they are now into the waste or the dustbin, but we want to reuse them. So there's a process where we take the waste and so that it becomes useful again. That is the process of recycling. It's recycling. Right. Number 128, which statement best explains resource depletion? When we are talking of depletion, when something gets depleted, it means it is getting finished. Something being depleted is getting finished. So the correct response is when a resource has been dramatically reduced. When a resource has been dramatically reduced. Right, what is meant by the sustainable use of resources? When you're talking of sustainability, with sustainability, we are saying the available resources that we have, they must not benefit only the current generation, but they must also benefit the other generations to come. Using those same resources, the generations to come after the present generation, they must also benefit from the very same resources. So which means we must use the resources in a way that does not damage the resources, such that in future those same resources are still usable and will still be able to satisfy the needs of the people who are going to come after the present generation. That is sustainability. So the correct response there for number 29 is A, when resources are used such that they meet the needs of the present and future generation. Right. Let's go to 30. Which method has been promoted by the government of South Africa for efficient usage of electricity? For efficient usage of electricity. Right. The response which is correct is D. Use of renewable energy sources. Use of renewable energy sources. Which are the most efficient ways of using water sustainably? How can we use water in a sustainable way? Right. The correct response there for the use of sustainable use of water, our response is response A. We fix leaks, which means we are avoiding water leakages and wastage. Take a shower. Instead of you taking a bath in a tub, use a shower which uses relatively less water, and also close taps. Those are ways of sustainable use of water. We are saving and conserving the available water resources. Right. Let's look at source 3, which talks about unsustainable use of resources. If you are using resources in an unsustainable way, we are damaging the resources. We are compromising the ability of those resources to satisfy the needs of the generations that are going to come in future. So the question is saying, based on source 3, identify the unsustainable use of a resource shown in source 3. What are those guys doing? You see, they are cutting down trees. That is deforestation, which is response B. They are causing deforestation. They are destroying the vegetation there. What role can consumers play when choosing more sustainable resource use? The final users of products, what can they do when they are choosing sustainable use of resources? What is the role of consumers in sustainability? They must use appliances with renewable energy source. Use appliances with renewable energy source. For example, using solar energy or using wind energy. Those are sustainable ways of resource usage. Right. Number 134. What do we call the strategy to sustainable fishing, where a maximum quantity of fish is allowed to be taken? A maximum amount of fish is allowed to be taken at a given point. That strategy is called a quota system. Quota is a restrictive, is restricted in terms of quantity. It's a quantity restriction, which implies that you cannot overfish because you will have attained a limit. If it's a daily limit or a monthly limit, then it means we are operating on sustainable ways by following the quota system, which is a restriction on the quantity of fish which can be extracted from the fish available reserves. Right, taking us to the next question. The question is saying, a habitat. What is a habitat? A habitat is basically a place where a specific plant or animal normally lives. That's a habitat. A place of residence of a plant or an animal, where an animal usually lives or where a plant is located. That is their natural habitat. Then number 37, right, it says the amount of carbon we create by using fuels that release carbon dioxide. Before that, we are supposed to look at 3.6. It says, name the process of breeding, rearing, and harvesting of fish. What is the process of breeding, rearing, and harvesting of fish? What do we call that? That is referred to as aquaculture. It's called aquaculture. We have agriculture and aquaculture. Agriculture for crops and animals. For fish is called aquaculture. Aqua for water. Right. What is meant by carbon footprint? I was reading the responses. The amount of carbon we create by using fuels that release carbon dioxide. That's the correct response at A. That is our carbon footprint. Our contribution towards the amount of carbon dioxide from our usage of fuels that release carbon dioxide. That is the carbon footprint. Right. We'll move on to the next question. Which are the major greenhouse gases? The greenhouse gases are those gases responsible for trapping the heat. The gases responsible for global warming. How they block the long-wave radiation. The heat that is being released from the Earth's surface is supposed to go back into space through long-wave radiation. But however, because of the presence of those gases, they tend to block the heat, and the heat does not escape, resulting in the rise in the global temperatures that we refer to as global warming. So we want typical examples of those gases that are regarded as greenhouse. We have a water vapor, we have carbon dioxide, we have methane, and also we have ozone. Those are our typical greenhouse gases. Right, number 39. What do we call substances that can be broken down into natural substances without harming the environment? Those ones that can be broken down, for example, plant matter, without harming the environment, we regard them as biodegradable. They are biodegradable, which is A. What is the aim of marine protected areas to sustainable fishing? We have some areas where there is protection of extraction of fish. Areas where you cannot extract fish because they are marine protected areas. We cannot do any fishing activity in such areas. So what is the aim of those areas towards sustainable fishing? What's the rationale? Is to provide a safe place for fish stock to breed and grow. If we have areas that are disallowed for fishing purposes, it means fish can safely stay in those areas and they can stock and also breed and grow in such areas because there is no hindrance and extraction of the fish resources in such areas which are protected. Right, number 41. How can businesses reduce their carbon footprint? We are now looking at the businesses. Remember, it's a three-sector where we're supposed to look at consumers on their side. We look at the role of the government. How does the government also assist in reducing carbon footprint? And then also look at the role of the business in trying to reduce carbon footprint. So we are looking at businesses. What can they do? Right. How can businesses do? They can do that by printing less and recycling paper. That's how they can assist. The number 42, it says, how best can eco-friendly products be explained? Eco-friendly, ecologically friendly. Right. We are looking at typical products that do little harm or no harm to the environment. They are ecologically friendly. They are friendly to the environment. So they cause little harm or even no harm. 143. Which way can individuals reduce their carbon footprint? An individual, how can we reduce the amount of carbon dioxide that we contribute through the usage of fuels that release carbon dioxide? Right, we as individuals, we must use energy efficient cars. Use energy efficient cars. It is going to help in reduction of the carbon footprint. We are going to contribute less to the amount of carbon dioxide in the atmosphere. What is food security? Right, we are looking at food security and insecurity. Food security, we are looking at a situation whereby all people have got access to safe and nutritious food for a healthy life. That is the ordinary definition of the concept of food security. So if I look at our responses, we are saying our correct response is D. When all the citizens of the country have access to nutritious food all the time. When we have access to nutritious food for a healthy life, that is food security. And the opposite is true when we're talking of food insecurity. When people do not have access to nutritious food, that they are experiencing food insecurity. Right, number 45. Identify 3 elements of food security. What are the elements of food security? The elements are highlighted in the response D there. 1, there must be availability. For us to have the food, it must be available. And then we must be able to get it through access. And then we must be able to use it. So it's availability, access, and use of the food. Number 46 says, what type of farming raises a large number of animals in small spaces for meat production? There is a large number of animals kept on a small space for meat production. What do we call that? It is called factory farming. Typical examples of zero grazing farming, it's factory farming. We keep a large number of animals over a small space for meat purposes. Right. Number 147, it is saying, what is the argument against factory farming? What is the argument against factory farming? We are saying we are keeping a large number of animals over a small space so that we can access them for meat purposes. What is the disadvantage of that? The disadvantage is that animals can easily catch diseases. Why? Because the animals are kept in very large numbers over a smaller space. If there is prevalence of a disease, such a disease can easily spread because the animals are always in very close proximity and in close contact, which will result in the transmission of the disease from one animal to the other until maybe the whole herd is infected. At number 48, it says, what does GM stand for? GM. When we are looking at animal or food products which are GM, we are looking at products which are genetic modification. They are genetically modified. So when we're looking at the GMOs, we are looking at genetically modified organisms. Right. What is the advantage of GM crops? The genetically modified crops, what is the advantage? What's the disadvantage, rather, not the advantage? One, the disadvantage. The disadvantage is that they may be harmful to humans. The way we modify them, sometimes they might produce negative implication on the health of some specific groups of people. So it can be harmful to humans. as compared to organically grown food crops, which are regarded more healthier than the genetically modified. So they can be harmful to human health. Then number 50, how can using appropriate farming techniques be of benefit? Appropriate technology, using relevant technology to our needs. It increases food production. That's the correct response. Which farming technique could prevent soil erosion? Which farming technique could prevent soil erosion? Right. The farming technique that could prevent soil erosion, we must have drainage ditches, and we must do strip cropping, and we must do terracing. Those are techniques that could prevent soil erosion. Then number 52, which of the following best explains the requirements of sustainable farming techniques? Which of the following best explains the requirements of sustainable farming techniques? Sustainable farming technique involve crop rotation. They also involve careful use of water and use of pest-resistant crops. Those are sustainable means of farming. Right. That takes us to the end of our section with multiple choice questions. We need to move on to section B and try to analyze those questions in section B. Right, there's a text here. It's a case study on agriculture as a contributor to soil erosion. How agriculture contributes towards the wearing away of the topsoil, which is soil erosion. Right, in this instance, we are seeing there is overgrazing, which is a cause of soil erosion, where we are seeing that head of goats grazing over on an almost bare land surface. And also, if we check here, it says contour plowing reduces soil erosion. If you can also see the contours there, which are cut across, we are cutting across a steep sloping landscape, which is a negative, is a positive implication on the environment and as a way of trying to reduce soil erosion. We are not going to go through the text, but we are going to analyze how we are going to answer the questions. Right, there is the text, how rearing animals can lead to soil erosion, and also how cultivation can lead to soil erosion. Right, so our questions are saying, how do humans contribute to soil erosion through construction? We are looking at construction here. How does construction contribute towards soil erosion? Right, when you're doing construction, it contributes towards clearing of the land or vegetation. If we remove vegetation to do construction, we are promoting soil erosion because the trees that we are cutting down, we are removing, will be responsible for binding the soil such that it is not easily carried away by the agents of erosion. And also the other issue, we can also talk of things like stormwater, water drainage. It can also contribute towards construction. Right. Then mention one way people contribute to erosion through mining. To erosion through mining, we can look at aspects like stripping the land. For us to do mining, we have to strip off the land. We have to cut down vegetation so that we can start the mining process. And also the other thing that we can also do there that causes erosion, we can talk about mine waste dump. Mine waste dumping. How does it cause soil erosion? Mine waste dumping, there are some chemicals which are dumped in the mine waste dumps. And those chemicals, they destroy vegetation. Which means as they destroy vegetation, they are facilitating soil erosion. The mine waste, the chemicals which are used in the mining process, as they are dumped with the mine waste, they destroy surrounding vegetation and also exposing at the same time the rocks to the soil to soil erosion because of the destruction of the natural cover of the soil. Right. Identify one poor farming method that leads to soil erosion in the case study. One poor farming method that leads to soil erosion. If we check here, is how cultivation can lead to soil erosion. If we look here, there is monocropping, which is growing the same crop on the same piece of land year after year. It leads to damage of the soil structure, leading to soil erosion. Then also using pesticides and chemical fertilizers is another thing. Then it also talks of planting crops in rows up and down hillsides is another way. So we just extract the answers from the given source. Right. Moving on to the next question. Define the following terms: defining soil erosion and also defining overgrazing. Soil erosion, we are saying, is the removal or the washing away of topsoil. What removes the topsoil is removed by agents of erosion. And what are the agents? Agents, e.g., we have one agent of erosion is water. Second is wind. It can happen by ice. So it's the removal of the soil by agents of erosion, which are typically water, wind, or ice. That is soil erosion. Soil erosion. Then we also want to define overgrazing. What is overgrazing? To overgraze. We understand grazing is the process by which animals feed on the vegetation available. But when it's over, now we are saying it's now excessive. So when we are defining overgrazing, we are defining it as the practice of excessive feeding of livestock. It's excessive, which means it's out of bounds, such that the land cannot recover its vegetation. Land cannot recover its vegetation. Like if we check here on the source, look at here, if we see this ground surface here, it has been overgrazed. We have excessively fed these animals on the available vegetation over the area, such that the area is even failing to recover, is even failing to produce enough vegetation to cover up for the soil. It has been overgrazed. It means it has been excessively fed, and the soil now is failing to recover, is failing to cover up for the lost vegetation because of excessive feeding by animals. Then, based on the case study, what is the impact of soil erosion on agriculture? Name 2 effects. Based on the case study, what is the impact of soil erosion on agriculture? Let's go to the case study. That is, sorry, before we look at that, there's a question again. We are leaving question number 2.5. There's question 2.5. What's the difference between subsistence and commercial? Between subsistence and commercial farmers. Right, when we're talking of subsistence here, the main purpose of these farmers, they grow crops and keep animals for subsistence, is for feeding the family. Subsistence farmers, they grow crops or rear animals to feed themselves and to feed the animals. And for commercial farmers, they grow, commercial in this side, they grow crops or keep animals for sale. To sell or for a profit purpose. So that's the difference. Subsistence farmers, those mainly are small-scale farmers. They grow crops or keep animals. They do agriculture for sustenance of their own food needs. While it's commercial farmers, they grow crops or rear animals for the purpose of selling and making a profit. That's the difference between those two. That's the major difference between those two. Right. Moving on to the next question. It says, based on the case study, what is the impact of soil erosion on agriculture? Name two effects. We just have to go to our case study and check for the responses. We're looking at how the question is saying, what is the impact of soil erosion on agriculture? Impact of soil erosion on agriculture. Right. If we check there, it talks about how rearing animals can lead to soil erosion. Keeping many animals to feed the grasses eaten up quickly cannot regrow. It is explaining. Then we come here. It is saying the soil is also compacted. It's an impact. Soil is compacted, and especially along the tracks of animals. Over time, it talks about the deep gullies called the dongas are eroded. That is the other impact. And also, we are looking at reduction of soil fertility is also another impact, which we can see there. The soil reduces in terms of its fertility. It's another impact. So soil is compacted, which means the soil particles will get more compacted because of erosion. And it also results in the formation of deep gullies forming called the dongas. And also the soil fertility is compromised, is reduced. Right. Those are some of the aspects to address on that question. Then going on to question 2.7, it says suggest two solutions to soil erosion on agricultural land. Suggest two solutions. How can we reduce soil erosion on land that we use on agriculture? Right, number one, we can do what we call contour plowing, which means we must introduce contours such that we limit the velocity of flow of the water down the steep sloping areas in such a way that if the velocity of the flow of water down a slope is reduced, it implies that its energy to cause erosion as it flows down the slope will be reduced, and ultimately that is going to limit the amount of soil particles that are going to be carried down the slope. Right, we can also talk of the aspect of crop rotation. It's also another sustainable way, crop rotation. Right, we must rotate crops. We must change the crops that we grow on a piece of land year after year, such that we maintain soil fertility and also we maintain the soil structure and reduce soil erosion. Then you can also look at afforestation, whereby we can introduce vegetation to cover up for the barren land. Afforestation, and also we can look at filling of gullies. Those gullies that you have developed, we must try to find ways of filling them, or what we can call a soil rehabilitation. Is another way that you can also do on agricultural land. Besides those ones, there are other ways that you can also try. We can look at aspects like planting grass strips. Grass strips, they can also help in reducing soil erosion on those areas that we use for agricultural purposes. Or can also look at plowing across the slope. It will also assist in reducing soil erosion on land which is being used for agricultural purposes. Right. That was question number 2. Let's move on. The next question is on overfishing. It says at source 5, overfishing is the removal of organisms from the marine environment by humans at a rate which cannot be sustained by the local ecosystem and therefore significantly alters the natural ecosystem. When overfishing, when fishing a population faster than it can replace itself, the population decreases in size as a result. Right. With reference to the statement above, write a paragraph of 8 to 10 lines and discuss the effects of overfishing. We are supposed to write a paragraph which is describing the effects of overfishing. You must have a topic sentence, the main points, and the concluding sentence. Right, I'll just highlight on the effects of overfishing. What are the typical effects of overfishing? Right, we have typical issues like the problem of reduction of the amount of food. Remember, we need fish as a food resource, which means if we overfish, we are going to have less fish. And also the other effect, it affects biodiversity. It affects the availability of natural animals. Mainly the aquatic ecosystem is affected. The biodiversity of the marine ecosystem is affected. Right. And also we look to aspects like unemployment. People involved in fishing activities, they will be unemployed because there won't be fish resources, and that will result in poverty. We also look at loss of income. Fishing businesses will lose their income because there won't be enough fish resources to sustain. Then you can also look at other aspects like collapse of the fishing industry. Fishing industry solely relies on the extraction of the fish resources, which means if there are no more fish resources, that industry is going to collapse and is going to be non-functional because of the excessive extraction of the fish resources from the fish reserves. Then we can also look at aspects like the other impacts that we can also look at. It also affects the ecosystem. The ecosystem, the balance of nature is also disturbed by that effect of overfishing. It can also result in higher fish prices. If you do overfishing and the fish reserves are limited, it means the prices of fish are going to increase. And as a result, it is going to affect the consumers at the end. Right, so if we are looking at those things that we've highlighted there, it actually gives a reflection of how overfishing can ultimately be of negative impact, both to the environment and also to humans and the economy at large, how it is going to impact on all those aspects. So that is basically the idea that you must address and make sure that you address the paragraph requirements of having a topic sentence where you address the question and then you write your points and then you conclude the sentence, the paragraph by writing a conclusive line at the end of your paragraph. So basically, learners, that was our discussion on geography. We just wanted to figure out how best we can try to prepare ourselves for the end of year examinations and social sciences, geography. So I hope this discussion is going to assist you in your preparations as you prepare for the end of year examination. Remember, your focus is focus on term 3 and term 4. We understand that term 3, it starts from surface forces that shape the earth, where we look at the process of weathering, also look at erosion and deposition. Then we'll go on to look at the rivers, where we look at the river processes and also the river landforms. That is part of term 1. Then as we move to term 2, we are focusing on resource use and sustainability, including the aspect of fishing and overfishing as part of the resources, and also including the aspect of genetic modification of crops and animals, and also basically the aspect of food security. Those are the focus areas from your final examinations for geography, social sciences. Right, that takes us to the end of the discussion. With that being said and done, I think this discussion is going to take you along in your preparation for the examination.